Now let's talk a bit more about things that could require you to modify this exclusive OR based hashcode algorithm. This code is a new equality comparer that I've written for the food item struct. It has the usual instance field and property to make it a singleton, and equals and get hashcode methods. Look at the equals implementation. It only looks at the name of the food item. This equality comparer says that food item instances are equal if their names are equal, and it doesn't bother about the food group field. If two foods have the same name but different food groups, then as far as this equality comparer is concerned, they are equal. That's perfectly okay if you have some reason for wanting to test for equality in this way. But you'd better make sure the hashcode matches this. At the moment, the getHashcode implementation does the usual thing of combining the hashcodes of the name and the food group, and that's not going to work. We can see the reason it won't work if we look at the main method. I've instantiated two food instances. One represents a beetroot, the vegetable, and the other represents pickled beetroot, which is sweetish and you can eat it as a snack, so it has the same name, beetroot, but I've given it the food group of sweets. I use our equality comparer to test if these values are equal, and also display the two hashcodes that the equality comparer evaluates for them. Let's run that. Here's the problem. The equality comparer says the foods are equal, which makes sense because their names are equal, and that is our equality test. But the equality comparer has given them different hashcodes. It's broken our rule that instances that evaluate equal should always have the same hashcode, and that will break any hashcode-based collection that uses this equality comparer. We can see the reason why the two hashcodes are different if we look back at the equality comparer. The food group is one of the operands used to calculate the hashcode, and it has a different value for the two instances. This field is not used to evaluate equality, so it shouldn't be used to evaluate hashcodes either. The fix for this is to change the hashcode method so that it simply returns the hashcode of the name, like so. Now I'll run that again. And you can see that the instances are equal and now also have the same hashcode, which is fine. And that illustrates an important principle with hashcodes. The only member field hashcodes you should use are those fields that are actually evaluated for equality.